All right, here's what we're going to do in this video. I'm now going to take together all of the theorems that we learned and what else we have learned previously about solving equations, about quadratics, factoring, and the Rational Root Theorem, the Remainder Theorem, and the Factor Theorem. We're going to ball it all together, and we are going to solve polynomial equations. So this could be a polynomial of any size. You could do this with a polynomial that is a 17th power polynomial, and you would still be able to solve it with this technique. Now, you may want to write down, there's 5 steps I'm going to show you here, and it can be, you could write it down as more than 5 steps, but we're going to work through this example here. And after this example, I'm going to do another video with at least a couple more examples. And I'm going to show you how you can take any polynomial and any polynomial with rational roots, and you can break it down and solve for x. That's what we're trying to do here, is we're trying to solve for the x value. We've got this crazy equation here. We've got this 4th power polynomial is equal to this other 4th power polynomial. It's pretty nasty looking. In most cases, I would probably just rely on technology, get a calculator out, a graphing calculator, and try and find the solutions. But if I don't have a graphing calculator, and let's say I'm out in, up in the mountains, and I have this crazy equation, I have to solve it, or a mountain lion is going to eat my head, then I'm going to want to do this by hand, right? I may only have like some dirt and a stick, but I'm going to figure this out because I know the Rational Root Theorem, I know the Factor Theorem, I know the Remainder Theorem, and I know how to factor and that sort of thing. So let's get to this, okay? All right, let's see here. So the very first thing you want to do is you want to set one side of your equation equal to 0. And I highly recommend that you make your lead coefficient positive. So we have a positive x to the 4th here and a negative x to the 4th over here. So I'm going to move all this stuff over to that side. So to cancel this negative x to the 4th, I'm going to add x to the 4th. That means I'm going to add x to the 4th over here. That's going to cancel here. To get rid of this 4x squared, I'm going to subtract 4x squared. And so I'm going to go to this minus 3x squared. I'm going to put minus 4x squared. Okay? All right. Cancel that. I got a negative 2x here, so I'm going to add 2x. Cancel that. And I got a 10x here, so I'm going to add 2x there. Okay? Here I've got a positive 16, so I'm going to cancel that by doing minus 16. And if I minus 16 there, I have to minus 16 over here. So now I'm going to do all my arithmetic here. I'm going to bring this stuff down. X to the 4th plus x to the 4th is 2x to the 4th. I didn't have an x to the 3rd term, so I'm just going to carry down the plus 8x to the 3rd plus 8x to the 3rd. Negative 3x squared minus 4x squared is minus 7x squared. 10x plus 2x is 12x. And 1 minus 16 is negative 15. Equals, well, this all canceled out, so this side is equal to 0. So I've now succeeded in step 1. I have set one side of this equation equal to 0. Okay? Now we're going to look, but we're going to ignore this side of the equation. Now we really care about this polynomial expression here. The next step, step 2, we're going to use the Rational Root Theorem to find all of the possible zeros. So remember, the Rational Root Theorem says you have to look at the first number, the coefficient of the highest power, and the last number, the coefficient, or not the coefficient, the constant. And those are going to give you, the factors of those numbers will give you your p's and your q's for all of your possible rational roots. So, negative 15, well actually really we just care about 15 because we're going to do plus or minus every number, so the signs don't matter. Factors of 15 are 1, 3, 5, and 15. Factors of 2 are 1 and 2. Those are the only two numbers that multiply to 2. 1 times 2 is 2. In fact, 2 is the only even prime number. So, all right, now we're going to put all these numbers, the p's, over the q's. We're going to make a bunch of fractions where these numbers are over these numbers. So 1 over 1, 1 divided by 1 is 1. And we got to do plus or minus. So here we go. Over here I'm going to put possible roots are plus or minus 1. And what that really means is that Positive 1 is a possible root, and negative 1 is a possible root. All right? Now 3 over 1, so that's plus or minus 3. So positive 3 and negative 3. 5 over 1, that's plus or minus 5. That means positive 5 and negative 5 are possible roots. Then 15 over 1, so that's positive 15 and negative 15. Now we're going to put all these numbers over 2. 1 over 2, that's 1/2. So that's 1/2 and negative 1/2. Then 3 over 2, so that's positive 3 over 2 and negative 3 over 2. Putting commas in. Okay, then we got a 5 over 2, so that's positive 5 over 2 and negative 5 over 2. Then we've got 15 over 2, so that's positive 15 over 2 and negative 15 over 2. So there are 16 possible roots. A root is a number when plugged into a polynomial will give you an answer of 0. So here's what you got to think about. Here's what you need to understand. If 1 is a root, positive 1 is a root of this polynomial, what is the factor that goes along with 1? It's x minus 1. So x minus 1 could be a factor of this polynomial. Well, what binomial goes with negative 1? Well, that would be x plus 1. What binomial would go with positive 3? X minus 3. How about negative 3? X plus 3. How about positive 5? X minus 5. How about for negative 5? X plus 5. Let me show you why. Because if I put this 1 in here, 1 minus 1 equals 0. If I put this negative 1 in here, negative 1 plus 1 equals 0. If I plug this 3 in here, 3 minus 3 is 0. Negative 3 plus 3 is 0. 5 minus 5 equals 0. So you can make, if you basically do, watch this, x equals 1, x equals negative 1. If I say, let's pick this one over here, negative 15. X is equal to negative 15. Now, make this equal 0. I'm going to add 15 here, add 15 here, and I get x plus 15 equals 0. That means x plus 15 is the binomial factor that goes along with negative 15. That's how I'm coming up with these. Okay? So, here's what I'm saying, is that if we find that negative 5 is one of the roots of this polynomial, then we know that x plus 5 is a factor of this polynomial. Okay? All right, so we've got all of our possible roots. That's step 2. Now let's go to step 3. You're going to plug all of the possible roots from step 2, that's what this list is right here, into the expression using synthetic division and looking for a remainder of 0. And what step 3 is doing here is it's combining the remainder theorem with the factor theorem. The remainder theorem would tell us what the answer is. Okay, the remainder theorem tells us that the remainder tells us what the answer is to the expression if we were to plug a number in. The factor theorem says if that answer is a 0, then that number is one of the roots, and its binomial is one of the factors of this polynomial. So here's what we have to do. I know you're going to hate this, but here's what you got to do. We got to take all 16 of these numbers, or maybe once we find out, we can only have up to 4. It can only be up to 4. We are going to keep trying them, starting with 1. We're going to try every one of them until we find all of the factors. Once we find all the factors, then we can stop. Okay? Hopefully we'll find them before we get to these fractions down here, but you can plug fractions in. All right, so here we go. We're going to do synthetic division with these numbers. We're going to start with 1. Let me get rid of this, the P and the Q. Okay? So, I'm going to plug a 1 in. And I've got 2, 8, negative 7, 12, and negative 15. Synthetic division. Put a 0 here. 2 plus 0 is 2, times 1 is 2, plus 8 is 10. 10 times 1 is 10, minus 7 is 3. 3 times 1 is 3. 3 plus 12 is 15. 15 times 1 is 15, and negative 15 plus 15 is 0. We just found one of our factors. We found one of our roots, the very first one we tried. It won't always work out that way, but this time it did. So what factor goes with positive 1? Well, that's x minus 1. So we know, we're going to make a list over here. What are the factors? One of the factors we know for sure is x minus 1. Now, here's the cool thing, folks. You gotta get this. Do you see these numbers down here, 2, 10, 3, and 15? That's what we would get if we divided this polynomial by x minus 1. And we did just divide it by x minus 1. Think about it. What number would you put in the half box if you were dividing by x minus 1 in synthetic division? What number would you put in the half box? You would put a positive 1, right? The opposite of this, minus 1, positive 1. That's what we did. And then if it was synthetic division, what numbers would you put across the top here? You'd put these numbers, 2, 8, negative 7, 12, and negative 15. And whatever you got down here, what would this become? What would this answer be right here? What would the answer be? It would be, the power would go down by 1, so this would be x to the third. It would be 2x to the third plus 10x squared plus 3x plus 15. Here's what I'm saying. For the rest of the numbers, we just did this one. We just identified that one, right? For the rest of these numbers, you don't have to plug them into this. Plug them into this. Because you've already broken it down a little bit. So with each step, every time you do another one in number 3, if you get a remainder of 0, use those numbers instead of the original numbers and keep breaking it down until there's nothing left. So now when we try negative 1, which we're about to try, instead of putting negative 1 in here and using these 5 numbers, we're going to put negative 1 in and we're going to use these 4 numbers. And we're going to keep breaking down the polynomial until it's in smaller pieces. So the numbers we're going to use are, in fact, watch what I can do here. I can actually just put a new half box here, put the negative 1 here, and now do synthetic division with these 4 numbers. All right? So I'm going to put a 0 here. 2 plus 0 is 2. 2 times negative 1 is negative 2. Negative 2 plus 10 is 8. 8 times negative 1 is negative 8. Negative 8 plus 3 is negative 5. Negative 5 times negative 1 is positive 5. 5 plus 15 is 20. Get a remainder of 20. That means that negative 1 is not one of the roots of this polynomial. Okay? So now we're going to go on to 3. All right. Get rid of this. Get rid of this. Get rid of this. We're going to use these 4 numbers because we've already broken it down with one factor, and we're going to put a 3 in. I'm going to put a 0 here. 2 plus 0 is 2. 2 times 3 is 6. 6 plus 10 is 16. 16 times 3 is 48. 48 plus 3 is 51. It's getting big. 51 times 3 is 153, and 153 plus 15 is 168. That remainder is not 0. Therefore, positive 3 is not one of the roots of this polynomial. All right, move on to the next one. Yes, you just have to keep moving on. You just got to keep trying numbers until you get a remainder of 0. Now we're going to try negative 3. So I'm going to put a negative here. Put a 0 here. 2 plus 0 is 2. 2 times negative 3 is negative 6. Plus 10 is 4. 4 times negative 3 is negative 12. Plus 3 is negative 9. Negative 9 times negative 3 is 27. 27 plus 15 is 42. Not 0. Moving on to the next number. Okay. Next number we have is, okay, so negative 3 is not a root. Positive 5. Let's put a positive 5 here. Put a 0 here. 2 plus 0 is 2. 2 times 5 is 10. 10 plus 10 is 20. 20 times 5 is 100. 100 plus 3 is 103. 103 times 5 is 515. Plus 15 is 530. not 0. Therefore, 5 is not a root of that polynomial. Now we're going to move on to negative 5. Negative 5. Put a 0 here. 2 plus 0 is 2. 2 times negative 5 is negative 10. Negative 10 times 10, or plus 10 is 0. Remember what to do with zeros in synthetic division? 0 times negative 5 is 0. Plus 3 is 3. 3 times negative 5 is negative 15. Plus 15 is 0. We found another factor. If the root is negative 5, then the binomial is x plus 5. There we go. So we've got 2 of our factors now. And now we can break this down. Or now we can look at this 2, 0, 3. But this is a little weird. We got a 0 in here. This is a little unusual. If this was an x to the 4th polynomial, then our first layer here, this was an x to the 3rd polynomial. What does that make this layer? It makes it an x to the 2nd power polynomial, right? So this is 2x squared. There's a 0 here. That means there's no x to the 1st power term. We're going to go straight over to the 3. 2x squared plus 3. Well, hang on a second here. 2x squared plus 3, that can't be factored. I have said this before, and if you didn't get it, you got to keep hearing it again until you get it. Any x squared plus a value, x squared plus 7, x squared plus 1.5, x squared plus 9, x squared plus 15, x squared, 7x squared plus 3. Any x squared plus a number is not factorable. This can never, ever, 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 ever equal 0. There's no number that you can put in for x and make this equal 0. That's because squared values are always positive. If you multiply a positive value times a positive value and add another positive value, you will have a positive number, never 0. And what that means is that this cannot be broken down anymore. It can't be factored. That means none of these numbers could possibly be factors. We have found all of the factors, and this is one of them. So our final factorization of this polynomial is 2x squared plus 5 times x minus 1 times x plus 5. That was step 3. So 4, divide out all the factors until the expression is in factored form. That's what we've been doing the whole time. Step 5, set all factors equal to 0 and solve. So we know that 2x squared plus 5 cannot equal 0. So 2x squared plus 5 cannot equal 0. Therefore, we're just not going to solve it. How about x minus 1? Can x minus 1 equal 0? Sure. Add 1 to both sides, and we get x equals 1. How about x plus 5? Can that equal 0? Sure it can. Subtract 5 from both sides, and x is equal to negative 5. And your solutions, 2 solutions to this equation are x equals 1 and x equals negative 5. And you have just solved a polynomial equation. Okay? Do you see what I mean by you have to know all these different theorems? So make sure if you didn't understand them from the other day, you better go back and watch those videos again and make sure you do all those problems, because you have to know the theorems in order to solve a polynomial equation. That's it. That's it for this particular video. Watch the next video. I'm going to go through faster, and we're going to do solve 2 more polynomial equations. Okay?